So we've shown one way to solve this problem. Now we're going to look at the two other methods. So the first one, the method 2, what I want to show is that it does that checking thing a little bit more explicitly. So here we use whether this thing is in bouquet. So then, conceptually, what happens underneath? So essentially, um, you can think of what happens is we are trying to determine whether something is in a list. So what we do is we can initially say we haven't found it, it's not in the list. So unless we actually find it, this is going to be our default position. So we need proof in order for us to believe it's in the list. So then we loop over all the elements in the list, and if what we are looking for is the same as the thing in the list in the bouquet, so for that we require both the species is the same and the color is the same as this thing in the we are looking through the bouquet. And when that happens, we have found it. So when we set the variable found to be true, and then we break. So these 5 lines here, 5 highlighted line here, shows how you find this something, whether something is in a list or not. So of course, this loop can also be implemented using range loop. So then we're just looking at the bouquet 0, bouquet 1 for check to see whether each one of them is the same as the SC. So that's one way to do it. This data structure of adding something only when it's not there, it already exists in Python. So this is known as a set. So mathematically, in math, a set is a number of things that there's no duplicating a set. So a Python set implement that. So then for that, we can simply just try to add whatever new things in the set. If it's already there, the set doesn't change. So it's not added. So this code use set. And at the very end, we just need to ask how big is the set, how many things have been added. Then that's the answer. So another thing I want to, this code is different from the previous version is we don't actually do any parsing. We don't do this split thing. So the reason is because each leaf is specified using exactly the same syntax. So the species followed by one space followed by color. So because this syntax is fixed, then 2 leaves are the same if and only if their string representation are the same. So we actually don't need to parse this into saying that this is a birch leaf of yellow color. We can just say this string describes the leaf, and the 2 leaves are identical if and only if their string representation are the same. So we don't need to use a split. We can directly just use this, just use whatever string that's read into, then this will be fine. So using the previous parsing logic, we can handle the case where what if there are more than one spaces here. So if we have not always fixed one space, then our split logic can handle that. Actually, let's show the code, run it. So suppose I have this multiple space here between birch and yellow. If I use this version, it's still correct. So it's still 4. But if I use this this version that doesn't parse, just take whatever returned as input, then this should give us 5. Yes, because this will not identify the delete this comment, and this will not treat this string as different from the first one, because obviously they're not exactly the same string. So, but we can still use set by just we just need to do the split thing. let's see whether this works. Not okay. So okay, so they don't like that. Okay, so actually this cannot be directly used this way because a list cannot be directly added into a set. In order to add a set, we need to hash it. So this is a little bit advanced. So we don't need to understand this now. But yeah, this only works when we just treat this as a string. So because input is reading as a string, for string, we know how to add that to a set. So again, this is actually beyond the scope of topic 3. I'm just trying to show you that if you want write something succinct, there is this data structure set that can be used. So hopefully in a later topic, we are going to explore how to use set because it is a very useful data structure for solving problems.